I want to talk about the standard normal distribution. The normal distribution is the one main example of a continuous distribution that we are going to study. And the standard normal, for the standard normal, the mean of the standard normal distribution is 0, and the standard deviation for the standard normal distribution is 1. When we get to other normal distributions, those numbers will change. But for right now, we're going to focus on this one. And probabilities associated with the standard normal distribution are calculated as areas under, this is the standard normal distribution curve. The mean, mu, is right in the middle. That's about 1 standard deviation. That's about -1 standard deviation. And the probability that a standard normal random variable is between two values is calculated as area between those two values under this curve. So for example, suppose the question was if x is a standard normal, find the probability, say that minus 0.5 is less than x is less than 1. In other words, the value that this random variable is between -0.5 and 1 on the picture. So there's my graph of the standard normal. 0 is in the middle, 1 is about there, -1 is about there. So -0.5 is about there, and 1 is there. So what we're talking about is calculating that shaded area, which represents the probability. Now, calculating that shaded area is really a calculus problem, but there's a built-in function on the calculator that we're going to use, and it's called normal CDF, and the parameters are the low x value, the high x value, the mean, and the standard deviation. So for this example, the probability that a standard normal is between -5 less than x less than 1 is equal to normal CDF. -0.5 is the low x, 1 is the high x, the mean is 0, and the standard deviation is 1. On the calculator, that's on the distributions menu, second vars gets you there, and it's the second thing, normal CDF, and my stat wizard is on, and that means that it's going to prompt me. The lower value is this -0.5. I'm using this negative symbol down here, -0.5. The higher value is 1. It defaults to mean and standard deviation 0, 1. And when I hit paste, it gives about 0.533 to 3 decimal places. 0.533. Now, sometimes the area is unbounded in one direction or the next. So as another example, say find the probability that a standard normal x is greater than 0.5, say. So for this one, the picture looks like this. There's the standard normal curve. Here's 0, here's 1, here's -1. 0.5 is about there. And greater than 0.5 means we're going to calculate all the area going out forever and ever and ever and ever. And on the calculator, to calculate that, I'm going to go normal CDF. The low x value is 0.5. Now, to put in a number that's really, really big, I usually put in 6 nines when it goes forever and ever and ever in the positive direction. Mean 0, standard deviation 1. So I'm going normal CDF, the low x is 0.5, and this time for the high x, because it's going on forever and ever and ever, I'm just putting in a very big number, 999,999, and comes out about 0.309, rounded off to 3 decimal places. We can do the same thing going in the other direction. So as another example, here's another example of x is a standard normal. Find the probability that x is less than 0.32, say. So here's the picture. Here's the standard normal. Whoops, that's not a good picture. Here's the standard normal curve. Here's 0, 1, -1. 0.32 is, say, about there. So less than 0.32 means we're doing that shaded area. Now this is going infinitely in the negative direction, and on the calculator, when I'm going infinitely in the negative direction, I'm going to put for the low x a negative 999,999. The high x is 0.32, mean and standard deviation. And on the calculator, normal CDF. Now the lower one, I'm putting this negative symbol, 999,999. The upper x value is 0.32. And that comes out about 0.626 to 3 decimal places. Okay, just one more comment about this. I'm doing this with the Stat Wizard on. If I had the Stat Wizard off, it wouldn't prompt me the same way. It would expect me to know what to enter. So if I turn the Stat Wizard off and do the same thing, if I go to that same distribution, normal CDF, see, it doesn't give me that prompt. I'd have to enter everything in directly. So if I went -1, 2, 3, 4, 5, 6, just doing the same example, 6 nines, comma, 0.32, comma, 0, comma, 1. Of course, it spits out the same number. I'm going to put the Stat Wizard back on. I'll leave it off for the moment. Okay, now we're going to turn the whole situation around. And sometimes they may, instead of asking you for the probability, which is an area, they may give you the area and ask you to find the corresponding x value or z value. Now here's another example. Suppose they give you a picture that looks like this, and this time they're going to shade in the area. Let's say that that area is 0.73. Find what they call the z value along the x-axis. Now, they might use z and x interchangeably here because, remember, a z-score is measuring in units of standard deviations. And for the standard normal, the x-axis is in units of standard deviations. So they may use z and x interchangeably. This time, the 0.73 is equal to the area to the left of this z value. And when they give you the area to the left, this can be calculated by using the function invnorm on the calculator, which is area to the left, 0, 1. So for this example, the z is going to be invnorm. The area to the left is the 0.73. The mean is 0, the standard deviation 1. And on the calculator invnorm, it's the distribution that's right underneath normal CDF. Let me clear this out so you can see. So it's distributions right under CDF. Area to the left is 0.73. The mean is 0. The standard deviation is 1. And this comes out to be 0.6128. So they usually round this off to 2 decimal places. About 0.61 would be the z-score that corresponds to an area of 0.73 to the left. Now they may also ask this similar question in terms of percentiles. So here's P10, P20. Now let me make more room there. In terms of percentiles, so here's P10, P20, P30, P40, P50 is right in the middle, P60, P70, P80, P90. So let's say they ask you to find P80. So P80 is the z-score along the x-axis that has an area of 0.8 to its left. So P80 can be calculated as InvNorm. The area to the left is 0.801. I think I'm going to turn the stat wizard on now so you can see how that works. Mode, turn the stat wizard back on. Get out of there. So now I'm going InvNorm. And notice it's going to give me a menu now. The area is the area to the left. This is 0.8 and it defaults to the standard normal. And when I go paste, it comes out 0.84. So this value along the x-axis is 0.84. And that would be the 80th percentile of the standard normal. Now let me do one more kind of example here. And this is what they call critical z-values. So here's an example. Find what they call z.07. This means find the z-score with area equal to 0.07, not to the left, but to its right. And so the picture for this looks something like this. So here's the z.07. The 0.07 is that little piece of shaded area. Now the total area under this curve is equal to 1. So if I know the area to the right is 0.07, the area to the left is 1 minus 0.07. So z sub 0.07 can be calculated as InvNorm 1 minus 0.0701. And you don't have to even do the calculator will do that for you. You can just enter 1 minus 0.0701 for the standard normal. And it comes out about 1.48 to 2 decimal places.